welcome to 9.6, Sectors and Segments. Before we jump right into formulas, I want to talk about the difference between an arc measure and an arc length. An arc measure is a degree measure that's the same as the central angle. Okay, so it is a portion of the 360 degrees of the circle. So it's always going to be less than 360 degrees. But arc length is actually a linear measure around the part of the circumference. So that's what this is saying here. If the degree measure of an arc is theta, okay, and the circumference of the circle is c, then the length of the arc, which is going to be in meters, inches, centimeters, okay, something like that, they're measuring the arc, is the script L, or in here it's like an italics, lowercase l for length. And this is the proportion. It's the length is the circumference as the angle measure or the arc measure is to 360. So we can then cross multiply and solve for L, and we will have circumference times theta over 360 degrees. Of course, there's a little bit of a input that we need to do. So by substituting the formula for circumference into that equation, this would be our official formula for arc measure. I'm sorry, for arc length. I keep saying measure. The arc measure goes in for theta. The arc length goes in for L. But we can simplify this even a little bit more, because 2 over 360 can actually simplify. Because 2 goes into 2 one time, and 2 goes into 360 180 times. So your length of the arc can be pi r theta over 180. Okay, so a sector, this is your first definition, a sector of a circle is the region that's bound by 2 radii and the intercepted arc. So think of a sector as a piece of pie. That's the easiest way to think of it visually, and I'll show you some pictures anyway. Then you have the segment of a circle. Now we know what the segment of a line is, but the segment of a circle is like the crust, the pizza crust. It's a region bound by a chord and its intercepted arc. So here we've got our sector, which is the piece of pizza, and the segment is the crust. That's how I remember them. The area of a sector, okay, remember the sector is the piece of pie. Okay, so the piece of pie area is area over area of the whole circle given theta over 360. So theta would be the angle of the central angle. So then you can solve for all of that, excuse me, where big A is the area of the sector, big A with the little c there is the area of the whole circle, and then theta is the arc measure. So we can also do a substitution here to make this a more complete formula. So substituting area of a circle, which is pi r squared, in for the A with the little c there, we can't simplify this anymore. Pi r squared theta over 360 is the area of the sector. Okay, so it says find the area of the segment. Well, the segment is just the pizza crust, right? So our first step would be to find the area of the whole sector by using our pi r squared theta over 360. Okay, and when we put in the radius is 8 and the theta is 60. Okay, that's how that's marked on there. When you simplify that all out, you will have 32 pi over 3 square units. Now that's the area of the whole pizza pie piece, the piece of pie. But what we need to do is find the area of the equilateral triangle that is formed when we make the chord here. So we're going to use our s squared times square root 3 over 4 because it's an equilateral triangle, and all we have is the side. So if we plug in 8 for s, we'll come up with by simplifying, you'll end up with 16 square root 3. So now we can do some. Okay, so that's the last step. You take the area of the sector and you subtract the area of the triangle, and you will get the area of the segment. There is no direct formula for the area of the segment. So this is the only way to find it. It's using two formulas you now know and subtracting one from the other to find the segment. So let's do another example. It says find the perimeter of the sector interpreting xy. So xy is we can draw a chord there, but we need to first know the arc length. Okay, that's the first step. So the formula for that, remember, is length equals pi r theta over 180. So our radius here, which is not written on the figure, I'm not sure why, but in your book it's a radius of 12, and the degree of the angle is 110. So when you simplify that out, you get approximately 23 units. But that is only the arc length. It says find the perimeter of the sector, right? That's only going around this part of the circle that is the arc. Remember, the sector is the whole piece of pizza. That's a big piece of pizza. Someone's really hungry. But you have to include the two radiuses. So I'm going to add the arc length plus the segment YU plus the segment UX, which are both 12. So 23 plus 12 is 47 units. Okay, so for your WSQ summary, I have some practice problems for you, but they're mostly on area. I feel like the examples gave you perimeters and talked about sectors, so I want to give you areas of sectors and instead of perimeter, because I feel like the examples covered that pretty well. Go ahead and submit these to me through email, and I will see you in class.